is Advent of Code, day number 18. And we've got about 2 minutes until puzzle unlock, so let's just go ahead and dive in. I prepared my input files, I've recompiled my copy of GoTip, so I'm pretty much ready to go. At this point, just waiting for the puzzle to unlock, and tomorrow I'll do a bonus stream to finish off day 16, because that day I did not get to. I wound up deciding it was too much work for my brain to handle, and I don't like to do more than one puzzle back to back if it's after a work day, so weekend is my soonest chance to catch up. One puzzle per day, that's where my limit is. So yeah, we'll just see how this goes. See what the status of the public stats are. Okay, yeah, so a bunch of people, including myself, didn't solve day 16, but the drop off from 16 to 17 wasn't too bad. But yeah, that dropping 6,000 people, that was a pretty big drop. It happens. Cool. Hope everyone's week has gone well. I certainly am feeling a lot more relaxed now that it's the weekend. So yeah, just looking forward to a quiet weekend home with my family. We are very much not leaving the house because, yeah, it is nasty in terms of the COVID numbers out there. So, yep, just staying home. All right, how long do we have until the puzzle goes? We've got about a minute. By the way, obligatory reminder, please check out my employer, Honeycomb. We're sponsoring Advent of Code. We would very much appreciate it if you all would check us out and see whether you find value out of trying to better understand your distributed systems. Sometimes we demo Honeycomb, sometimes we don't. It depends on whether or not the problem that Advent of Code is doing that day is appropriate for conversion. All right, so with that, let's go ahead and get this open, and we'll get going. Gosh, past couple of weeks have felt like 2021 has some real plot twists at the end. That's all I gotta say about that. Ooh, we're almost at the bottom of the trench. That'll be cool. I wonder whether there's another cave down there, but I guess we'll find out. Okay, here's day 18. Aha! Some snailfish came. Oh, okay, this is arithmetic. Yep. Yep. Okay, to explode a pair. Okay. Okay, I think I understand this. Yep. Okay, and numbers can only appear in pairs, I think, right? Yeah, it's always a pair, which can either be another number or... Okay, I love these kinds of puzzles. They're super fun. Great, okay, so... add up all of the numbers in the order that they appear. Great. So we have that. Okay, so we just need to construct the data structures and do the lovely and fun stuff. Hey, Eric. All right. All right. Let's do it this way. And we also will have a... Oh, I've got this backwards. Okay, so something like that will work. And that way it can either contain a number or contain another pair. All right, so let's do the input construction, and then we'll go ahead and do the and then after that we'll do the do all the operations on it. Okay, so for a given number, we're going to read it left to right. Something like that. All right, so let's just make sure that we have this correct first. So up here, all right, so reading from left to right. So we need to tokenize this. The possible tokens are can we even recursively parse? Yeah, I think we can probably actually, yeah, no, in fact a recursive parser is better. So let's just do recursive parse. What do we have? So we expect so if we don't have this, then we know we have a problem. Okay. So let's just do that for now. Okay. So now I'm going to take the inner so how do we can't just do a naive search. We basically need to start from the next character. So we either have okay. All right. The question is, once I have a how do I approach this, right? Like the problem is that I need to break this down over here. Right, so I can't necessarily use the first time I encounter a right brace. So I need to somehow know when the braces line up next. So Okay, so we're reading until we encounter a comma, because once you get in that far, like, it's just going to be the next comma. And in fact, wait, are all of these things single digits? Let me just check this. How does this work? There we go. Okay, so that works like that, but are there any double digits? They're not double digits. Okay, great. So that makes that simple. Okay. That is a useful simplification to make. This is why you read your inputs carefully, folks. All right, so then okay. So we start at position 1. So now, okay. Oh, that's going to be position 2. Or, no, position 0, position 1. Yep, so then we also have this problem here. Okay. So now we can proceed to parse the right part. Okay, otherwise, we need to read matching ren to find the substring to recurse. Okay, so how do we do that? All right, so in this case, what we have is so we start from index 2 now. How do we handle this? Okay, so wait a second. If there are commas, no, we don't need to care about commas. We just need to care about the brackets. Okay. At the end, this should result in ret left p equals parse from index 1 onto I think that should do it. So now what do we do here? All right. So if the brackets are balanced, then we break. So in fact, we can just simplify this logic. That should do the trick. No, but we do need to iterate the, okay, I see. Bracket count equals 1. Okay. If s in xi this is actually better expressed as a switch statement. I forget whether bytes and runes automatic convert, because that would save me a bunch of stuff. Let's see, are they automatically? Yeah, blah 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 blah. You know what? I'll just do this, and if the compile, and then I'll take one away and see whether the compiler complains. It's going to be the best way. Okay. Okay. I think something like that will work. All right. So we're checking position 2. If it's a 4, if it is not a brace, then it's a number, and then we'll hit the end of this, which is going to create a closed brace, which will bring bracket count down to 0. So at that point, I will be equal to the position of the closed brace. So we need to advance 2 past that. Okay, so let's just try running that so far. I'm sure I have some bugs in here that I should flush out. It is definitely helpful, thank you, Eric, for making all of the digits here single digit. Okay, what else did I do? Oh, yeah. I remember what I was going to say. Bracket count 1. Okay. Oh. There we go. Okay, so that code didn't complain, so that suggests that we're on the right track. So now we need to just parse the right-hand side now. Okay. So Actually, this logic would read a lot cleaner if I did this instead. Let's swap the if and the else, just for sake of my sanity. Okay. Okay, so in this case, we will simply do this. And we've already checked the ending at this point. In fact, come to think of it, the way that I could have solved this actually is if it's a right-hand side single digit, it'll always be the second to last digit. So that's another check that I could have used rather than reading position after comma, but that's okay. That will always be that, I think. Yep, that passes my input checks. Wonderful. So now we just need to deal with this, which is going to be, in fact, we know this, so I think something like that will work. Okay, wonderful. So let's just, let's now actually do it this way, just to print some values, just to make sure they make sense. So for instance, we should see, oh, I need a print function. Very well, very well, very well, very well. Okay. All right, so something like this will work. So actually we'll just have it just print a naked string, that's fine. Right, and we basically have the same thing here. The printing is the simple part, the parsing was the harder part. All right, I think that looks good. Okay, so now let's just check this. All right, all right, let's just check it really quick. Okay. Oh, whoops, I forgot to print commas. Commas are important. Wait, where did that... how did that even compile? It shouldn't have compiled. Okay, well, that's fine. Right, so where'd this, oh. All right, so this should precisely match what we got as our input. So let's go ahead and verify that really quick. Ah. All right, so this will reveal if I have any problems. Great, that diff is clean. So that means that I have parsed my input correctly. That is the first step towards getting anything at all working. Okay, so now we need to write functions to handle explode, magnitude, and yeah, we need to do explode, magnitude, and split. Add the first and the second, and add the second that to the third, and so forth until all the numbers in the list have been used once. Okay. So once no reuse actions apply, the snailfish number that remains is the result of the addition operation. Okay. Cool. So when you add them, you... Okay, great. So let's do this. Yeah. This is super fun because I always like constructing types. So this kind of makes this, honestly, this really makes my day. We'll do it like this. Right. So we need a for a pair from the left and the right. Okay, so n. No, I prefer to just work with pointers in general. Okay, so, or do I? No, I would rather work with non-pointers here because here this one does not mutate. So all right, left nil, right nil, left p n, right p m. Okay. All right, so we do need a depth. So let's do that. So this doesn't I think we need to do that. Okay. So over here, do it like this. All right, so nested inside 4 pairs. Let's just triple check that we understand this. So this one has been nested 4 times, but at this point it's no longer nested to depth of 4. Okay, so this number, let's just check this. So this will have a depth of 0, but actually it should have a depth, yeah. Inside of this pair, it has a depth of 1. This pair here has a depth of 2. This pair here has a depth of 3 and it stops. Whereas this one here is 1, 2, 3, and that 4 on the left-hand side is not affected, but this one will, in fact, get a value 4. Okay, good. Okay. Good. Just checking to make sure that I understood that correctly. Okay, so... All right, so here... that's incorrect gross syntax. There we go. P.depth plus plus, and if left P is not equal to nil, then P left P dot expand depth. And we do the same thing for right as well. Okay. Cool. During reduction, at most one action applies, at which point it returns to the top of the list of actions. Okay, great. So now, reduce will modify in place, and that is fine. In fact, actually, I am okay with just making these things mutable. That's okay. We'll mutate them as we go. That's fine. So now the reduce function is going to first attempt to perform explode, and then we explode it before. Okay. Okay, so a explode action let's see what this logic says. The 8 gets added to the 1 that's to its right. Ah, okay, we have another problem here, which is these need to know who their parent is. Because otherwise I can't do the tree walk correctly. Where were we? Okay. Alright, so these guys will have a nil parent as well. And over here, we sum two numbers. They still have a nil parent because the summing can only be done at on top level operands. Okay. You must repeatedly do the first action in the list that applies to the snailfish number. Okay. So we'll explode it first. Then we'll break out. And then, after that, we perform split. That should do the trick. So split is the more obvious one. So let's just do split real quick. Replace it with a pair. Okay, that's fine. So it's over 9. Then we'll do it that way. So left is going to be the oh, wait, no, split. Split. Okay, regular number divided by 2 and rounded down. Divide by 2 and rounded up. 10 becomes 5, 5. 11 becomes 5, 6. Okay. Got it. So left is going to be, we round down when we perform this. That should basically do what we want. Okay. How's the difficulty of AOC scale? Each day gets harder within the same year in general, but there are exceptions to the rule. For instance, this is a weekend on the calendar, which means that the puzzle is going to take slightly longer than on a weekday, but it will be more difficult than a weekend 7 days ago, for instance. All right, so we'll just go ahead and do the walk like that. Finally, if we have no action to so split, we read from left to right. Okay. All right, yeah, because that makes sense that you might have to split multiple times. Okay, p left p dot split. Okay. All right, so similarly, we have something like this. Okay, that looks fine now. And that gets replaced here. All right, and then we do this, and then we return false. And that's how we do the tree walk. Okay, so I think that pretty nicely covers yeah, that pretty nicely covers the split case, so now we just need to cover the explode case. So in the explode case, okay. So if its depth is at least 4, then the leftmost such pair explodes. Okay. Otherwise, he left explode, or left p explode. Okay. Otherwise, we walk left and then right. Okay. So what does exploding ourself look like? If we explode ourself, look for somewhere to stash left value. Then look for somewhere to stash our right value. Okay. Okay. P parent dot. Oh, I have to keep track of whether I'm the left or right element to erase myself. Hey, Viwu. You are quick, Viwu. Thank you for the energy. I appreciate it. How shall we... Oh, no, but I do know... I can tell by memory address who I am. That's fine. So I don't actually need to do that. Okay. Okay. So... How do we do this? Stash left doesn't need to return anything. Oh. Let's think about this. let's pass the value. All right, and then we'll have p stash right as well. Okay. And then the entire exploding pair is replaced with the regular number 0. Okay, yep. Something like that will work. Okay. Couldn't find self in parent to delete. Okay. All right, so let's think about this. So if I'm being asked to stash to the right, okay, yeah, let's just put this code in here anyways, just to be safe. Safe and paranoid is better than having weird edge cases. Okay, something like this. Okay. So how does this work? So if I'm on the left side and I'm expected to stash right, then then that means we're done. Otherwise, we need to recurse. P parent right P stash right. Is that going to do the right thing? No, that's not going to do the right thing. I can't just do this the stupid recursive way. I have to keep on going. Okay. How do we do this? Okay, so we also need this, I fear. That comment now no longer makes sense. Okay, how do we handle this? This is just part 1. I wonder what part 2 is going to be like, but I guess we'll find out. So a stash down right from the left side. All right. Oh, that needs to return a bool for whether it succeeded. Okay. Otherwise, actually, am I guaranteed to reach a number if I reach into a new pair? Yes, I am, because there always will be a number somewhere at the base of it. Okay. So actually, I don't need this this true false. This will always find a place to land. Okay, so yeah. Okay. So that doesn't need to return a value. Okay. Oh, so in that case, yeah, so either we go directly into right, or we stash into the first left that we find on our right side. Great. Okay. That makes total sense. So yeah, in fact, I don't need these else's. I think these just automatically will happen. Okay, so otherwise, if we're on the right side, then we need to keep on going up our parent tree. Is that correct? Let's think this through. Yeah, I don't know when this Twitch category was added, but I definitely like its existence. Okay. Okay, stash upright. So we're starting. Let me just talk through this. Okay, so the right-hand side will have to look at its parent, and if I'm on the left-hand side, then I can go directly. I can just step down. Oh. going to be, so it goes up the tree, and then it goes to the right and down. Just wishing that I could simplify this logic somehow. But that's okay. Okay. This use of parent does not sit right with me. That's the main problem. The problem is I do need to know who I am, so therefore, okay. You know what? Let's just replace this. And then that'll make me feel better. Okay, now this makes it clear. So we're talking about applying to our parent's parent to stash. Right, okay. So now I think I basically need to do the same thing. And if there is no parent, then we're done. Okay. Okay, so these pieces of logic I feel reasonably sound about. It's just the stash up that worries me. Stash down left always starts from the right side and should always find somewhere to land. That's true. Okay. So in this case, we're... Okay. All right, so let's... As we copy this logic, let's make sure that it still makes sense to us. Whoa, that was the wrong button. That's fine, okay. Okay, so stash up left. So if we are stashing to the left, but we were on the right-hand side of the pair, then we can just go directly into our parent's left. Otherwise, we can stash down left into our parent. But if we were on... But if we were already on the left-hand side, then we need to go up a level. And that's going to be stash up left. Okay. Let's try that. Okay, and then after performing the explode, we replace ourselves with the regular number 0, which we did already. Okay, great. So let's try running this. So I'm going to try running it on a simple input first. Which is going to try adding these numbers. So we'll do this. How shall I do this? Sum is going to be the 0th number. All right, and if I is 0, then we just skip. Otherwise, sum. Where did I put sum? Yeah, sum here. Wait. Oh, I realized I have a problem. Up here, it's possible for a split to then result in the need to explode, I think. Okay, how do I handle this logic? So we're I think that should do it, because that always loops the top of the list. I think this reads okay to me as well. Okay, so sum. Dot reduce. All right, let's try that. All right, line 118. What did this need? Oh, right. Oh, wait, that goes here. Okay, line 27. Ah. Okay. All right, getting closer, line 53. Oh. All right, line 149. What didn't it like there? Oh, yep, those are pointer references. Okay. Oh, that's the same thing here. And line 268. Oh, and it has no parent. Did I pass the parents correctly inside of here? Yeah, I did. Yep, that's correct. Okay, no pointer dereference on line 117. Why would I be calling explode on something that's null? Oh, right. Okay. Cool. Okay. So that first one yields the correct answer. Oh, and I can let's do that. So now we run again. And we get another null pointer dereference, which is fine, on line 123. Okay, this is something that's wrong, because we should never have the situation where our depth is greater than or equal to 4. Yeah, the depth should never be greater than or equal to 4, and yet the parent does not exist. So that's clearly a problem. Wait. Hold on, I'm not sure I got... Let's run that again. I'm pretty sure I actually got the... Do this correctly? 1122 inside of those braces, yep. And then 3344. Wait. Let's diff that really carefully. 4 braces. Close, open, close, close, open, close, close, open, close, close. Okay, that's correct. Okay, great. Yeah, okay, so I'm just not tracking things correctly. So we talked about explode. Exploding pair replaces the regular number 0. Split a regular number, divide it, replace it with a pair. Okay, so my split is probably wrong. P.depth plus 1. Yeah, that's correct. How do I do this? Okay, where's this called from? So I called reduce, explode, 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 explode all the way down. Okay. Right, so... one second. Let's just tidy this so that all of my braces are in the correct place. Because stash up left and stash up right should never modify the pointers. Yeah, I'm not sure. Hi, Anthony writes code. I'm apparently the person who's running the latest today. Okay. I'm still stuck on part 1. That's my situation today. Oh, and I will eventually want magnitude, but I'm not even there yet. I'm just trying to figure out the, I've got a silly bug. Like, I know most of my logic is probably fine. It's just the... Wait, I think I know what my problem is. Let's try getting rid of this for the moment, and let's try checking whether my depth tracking is correct. So the original elements that I'm creating have a depth of 0. So when I print, I'm just going to really quickly let's do this really quickly. Okay, so this has a depth of 0, 1, 1, yep, 2, 2, 3, 3. That's correct. Okay. So the problem is not the core parsing then. The problem is okay, so we're going to, inside of our explode function, I'm going to print the current status. Let's see what's going on here. Okay, so now let's run it on 5.5 to get our first explode happening. So I have an inner 1, 1 with depth 4, which is correct. Oh, I see my problem. Yeah. Okay, I understand what I have done wrong. This here is wrong. This is not necessarily true. When you're summing these two things together, we need to also set... Yeah, okay. Yeah, that's... I understand what I did wrong. Okay. Well, that is a relatively simple bug to fix. That is just literally this. Actually, no, it was fine the way it was before. Except for what we're going to do is we're going to do this, and we'll return a pointer to ret. That will fix it. Okay, let's try that now. Okay, so now that yields... Oh, now I don't need my depth number. Okay, don't need this depth number, so now let's try running this. 3053 4455. Okay, so I'm adding to the wrong number here. Okay, I see that. So the problem is in my stash up right is doing the wrong. Yeah, stash up right is doing the wrong thing. If I am the left parent, then I should be doing that. Stash down right. Yeah, so I am, let me just check this. Yeah, okay. Yeah, so that should rightly be 3, 0, but I should have stuck it here on this 3, and yet I did not. And instead it went over here. So why would that happen? That would happen if I were the right element in my parent and I recursed one layer too far up. So if I am the right, oh, I see the problem. So this stash up right is not correct. The stash up, so it's just parent that stash up right. Is that the problem? Yeah, I bet that's my problem. I knew there was a problem with too many parents in there, because I'm already calling stash up on myself. There we go. 3, 0, 5, 3, 4, 4, 5, 5. Okay, that looks good. So now let's do the larger example. And I've got a null pointer deref, line 126. Okay. Okay, let's just work the 6, 6 case then for now. And let's see what that does. See whether I got too greedy. 5, 0, 7, 4, 5, 5, 6, 6. Good. Okay. Oh, I see, but I can work this problem one line at a time until the thing goes explodey. Okay, so let's do that now. Okay, so that already explodes. Let's take off one more line and see whether that explodes. Yep, okay, that already explodes. Okay, so now I know that I have a... Yeah, okay, that's just going to return the input itself. Let's just add 0, 0 to it and see what it does. Oh. That's exciting. Okay, so that's just purely because exploding this one does not work for some reason. Right, all of the numbers in here have a maximum depth of 3, 0, 1, 1. Yeah, these are buried a maximum of... this one's at zip 0, 1, 2. Yeah. Yeah, okay. Okay, so this is a solvable problem. What am I doing wrong here? Creating a new pair. What did I do wrong? Okay, so let's look at the stack. Just to understand what it's done. So it's 1, 2, 3, 4, 5 deep. Okay, that's wrong. It's line 126 and line 146. 126 is here. 146 is here. So we're exploding our right. Oh, I see. when I create the element that is, do I create a new pair? Split a regular number, replace it with a pair. Yep, so split replaces with a pair. With that, but those are always scalar numbers, and I've set p and p.depth. Okay, that's fine. Yeah, I'm genuinely not sure what's going on here then. If any pair is nested inside 4 pairs, the leftmost such pair explodes. Oh, but can that have... I think that's it. Nope. Because I'm trying to not explode things that are... Now, actually, I might need to bury the furthest... What does it mean for something to be... What does it mean for something to be leftmost? Right? So what if something were super, super, super deeply nested? To the point of having its own items. Oh, exploding pairs will always consist of 2 regular numbers. Ah, okay, that's the condition that I missed. Yeah, okay. Okay, now that makes more sense. Now let's try running that again. Still invalid. So we have run, explode has run 5 deep. Original 1, 2, 3, 4. Yep, so that's the first time in which it would potentially be, yep, okay. So where am I creating pair? Parent. Parent. Split a regular number. Yeah, I'm pretty confident we're doing split correctly. We're setting left p-parent and right p-parent. Yeah, okay, I'm not sure what's happening here, so stash up right, stash up left, okay, that looks fine. Let's try that just to see if I understand what's happening here. Okay, so that inner 4-5 doesn't seem to have a child. Why does that 4-5 here not have a child, or not have a parent? That could only be explained... Okay, so then it's my parsing code that's at fault. Okay. That's a solvable problem. Yeah, because I wasn't checking the parents in my... Because all of the initial examples were not nested initially. Okay. Yep, now I understand what I did wrong here. Okay. So down here, when I'm parsing... Yeah, this I'm always returning nil, but that's not necessarily true. Okay, so... Oh, yeah, because this is actually here. This is ret. Okay, that's what I got wrong. Yeah, I see the problem. And this main function here passes nil here. Okay, so I just added nil in the wrong places. Okay. I'm panicking somewhere else. Line 126. If we recalled... Right. Yeah. All right, so now let's check this. If I'm left p dot parent not equal to p, okay, let's add these debug lines here, and let's see what has gone wrong. Yep, okay. So I have a defective child even... Okay. So when I'm creating the left-hand side, I'm apparently not doing that correctly. So, okay. So pair is instantiated here. And we set parent, that's not null. Pair is instantiated here, we set parent, not null. Pair is instantiated here, but whenever we have a sum, we're creating a root node, that's fine. And we're setting the left and right node's parent to ourselves, that looks okay. So that leaves us with where is parse? For ret pair, ret depth is depth, yeah, that's fine. Left p is ampersand ret. Oh, that's wrong. Oh, I'm not... Got it. Yeah, I was not setting that there. Well, glad to have caught both of these bugs. That would have otherwise been a little annoying. Okay. Now on line 151, we're wrong. Oh. Now my null check is just bad. There we go. So that should yield, okay, so now let's plug in this. There's so many fun and interesting edge cases here. Okay, so that first sum should come out to 4054776087777950. Okay, so now I'm pretty sure that I have something that's working. So let's go ahead and remove the defective child checks. So I don't think I need them anymore because I think I've caught all of the problems where parents could be created, where a parent could be set to nil. Okay, so now let's feed in this file in full and see what happens. Well, it doesn't crash, and it gives a final sum 8777, 8677, 0766, 87. Okay, that looks good. So now I just need to be able to compute magnitude. Okay, so all right, so the magnitude is just 3 times so sum plus equals 3 times star p dot left. Oh no, the magnitude of a regular number is just that number. Okay. Else sum plus equals 3 times p dot left p dot magnitude. P right is not equal to nil. That just has that added. Okay. Straightforward. And this magnitude is going to be 2 times the magnitude of the right element. Okay. That's good. Okay. Okay, so now that I've got the example homework assignment, let's just feed in this one. See whether we got it correct. $16.38, which is wrong. Okay. Let's see what I got wrong here. So that final sum is correct. 6676, 7770, 7777, 7899. Okay. Yeah, so the problem is not this. The problem is now just my magnitude computation. 3 times 9. Oh, no, I had it right in the first place. This is correct. It was just not clear. The wording was not 100% here. Okay. So now I run it on my sample input. I get 4140 as expected. What's the magnitude of my final sum on the full input? 3806. That's correct. 1 gold star. All right. What's the largest magnitude that I can get from adding only 2 of the numbers? Okay, that's perfectly reasonable. And now we've built all the operations, so yeah, part 2 is actually reasonably quick. The problem is just that I've mutated the numbers in the course of doing this. So what we're going to do is we're going to construct this, and then for this, we're going to construct a brand new number, and I think if I do this, it'll leave the original values untouched, I hope. Actually, no, does that copy by value? Yeah, it's fine. That I think is a copy by value. Make sure that's still correct. Whoa. That exploded hilarious. Oh, go routine stack exceeds 100,000 byte limit. That's exciting. Did that explode before? Okay, no. So I'm okay. That's fine. I can make a copy of the original list. That's okay. We'll just do it this way. That's okay. So for some reason, doing it this way was okay. Okay. Right, so we just need to perform a deep copy, or we can just actually let's do this again. That'll be simpler. Okay. Okay, so something like this will work fine. J, Y, and range split. If I equals J, continue. All right. So if max magnitude is 0. Right. Okay, this code should basically do it. That's not correct. It is too high. Okay. What am I doing wrong here? All right, let's do the simple input for a second. But my running sum was fine. Oh, it's not commutative. Yeah, that's fine. I'm not assuming it's commutative. Oh, because I didn't reduce first. That's why. All right. Okay, that should do it. So now that yields 3993 as expected. Okay, that was just a silly rookie mistake. Hey, Epsilon. Okay, that was correct. Good job. About an hour and a half. That was fun. I liked it a lot. Thank you, Eric. That was a lot of fun. Okay. So let's go ahead and close this file, and let's tidy up our code, maybe. Thank you, Eric. I really enjoyed this one. This one was good. Maybe tomorrow when I'm doing my extra stream, I'll go ahead and add some tracing to this and show people how the what it's actually doing under the hood, because I think this one is a awesome example of recursive debugging, and I think that this recursive debugging actually probably, had I thought to use Honeycomb, it would have gone a lot faster. Because I would have caught some of these things earlier. Yeah, but you know, I'm pretty happy with this, honestly. I think the main thing that I want to clean up right now is I want to clean up that, like, whenever you sum, you should always reduce. Like, you should just always reduce it. Like, it's user hostile to insist that people always have to reduce manually. So I'm just going to find sum, and I'm going to just always do this first, and that should do the trick. All right. Okay, so now I don't need this, and I don't need this, I think. And I think that'll avoid the thing that tripped me up and make that a nice little one-liner there. Okay, let's try that. Uh, 4727, was that correct, or is that too big? Yep, that's correct. Okay. So having fixed the one thing that was most likely to trip someone up, I think we're good. So I'm just going to go ahead and commit this. And thanks for tuning in, folks. And I will see you tomorrow, probably middle of the day. I'm going to do a stream to solve day 16, which I abandoned earlier. All right, let's go ahead and commit this to GitHub and push it so that you can have a look at it. It is now up, github.com/lizthegray/advent of code. And yeah, honestly, it wasn't the, day 16, I was going to be in the right headspace to do parsing if I just weren't super tired after a day at work, but that is okay. Sorry, this is day number 18 here. Right here. So that's what I have for you, and yeah, let's go ahead and hand it over to someone else. But before you go, again, hey, if you're here, welcome, thank you for being here. Please do check out my employer Honeycomb. We're a sponsor, and I sometimes do visualize what I do in Honeycomb, so that's a lot of fun, but I'm not going to do it right now because it's been a couple of hours. So let's go ahead and rate Irene's. Cheers, folks, and see you all tomorrow, midday.